So in this example, we need to determine if the series of n minus 1 over n cubed plus 1 with n from 1 to infinity convergent or divergent. So we're going to attempt to apply the comparison test. That means that I need to find a sequence for which I know whether it's convergent or divergent, such that I can compare terms of that sequence with my sequence. But the problem is that when we have expressions that have several terms in the numerator and several terms in the denominator, it makes them harder to be compared to other expressions. So to take care of that problem, what I'll do, I will actually separate this series into two series. I'll split it up this way. I'm gonna look at the series of n over n cubed plus 1. And then, well, I'll say minus, so I will look actually at the difference of two series. I'm using that negative sign to put in between them. Minus series of 1 over n cubed plus 1. And now that I look at each, their general terms are a little bit easier expressions to be compared to other expressions. Let's work on one at a time. Oh, and I have to note here that using the properties of series, we know if both of them are convergent, then the resulting series is going to be convergent. Now, if we find that one of them is divergent, then we won't be able to finish it. But let's see what happens. Let's focus on the first one. So I'll rewrite it. Now I'm going to think what the general term of that series can be compared to. Well, it has n in the numerator, so I really want to compare it to something that also has n in the numerator. This way, the numerators will be the same, but denominators can be different. I just want to have them in such a way that it's easy for me to compare them. If I write the denominator here that does not have this one, this will make them easy expressions to compare. Well, so let's compare. Now, the numerators are the same. And I can say that the first denominator is bigger than the second one, right? So when the numerators are the same and the first denominator is bigger, it means that I'm dividing by a bigger number. That makes this overall quantity smaller compared to the second one. So I will use less sign. So I found something that can be compared to the general term of my series, but is it going to be useful? Do I know anything about series defined by this term? Let's think. I don't recognize it right now, but as I look at it, I actually realize that it can be simplified. So n over n cubed can be simplified, and I can write it as 1 over n squared. And now that looks like the general term of the p-series, right? But let's see if that p-series is going to be useful. So it's going to look like this. N goes from 1 to infinity, 1 over n squared. That's p-series, where p equals 2, right? The power is 2. That is greater than 1, and that means that this p-series, convergent. Now, is it something that we can use? The fact that it's convergent, so let's think. So we're now, going over the comparison test. But the way I think about it is the following. So I know that series with larger terms is convergent. That kind of guarantees that if I add up smaller terms, then that should be also a finite sum, right? I shouldn't end up with infinity. Okay, so if series with larger terms is convergent, then series with smaller terms should be convergent as well. So this one is convergent by the comparison test. Let's look at the second piece right here. And it goes from 1 to infinity, 1 over n cubed plus 1. So what can we compare this general term 2. 1 over n cubed plus 1. Again, I'm going to obtain an expression that has same numerator, 1, and expression in the denominator, it's going to be easy for me to compare it to mine, is n cubed, right? I'll just remove that constant 1. Now I can say, so it's kind of similar situation, right? I can say that this denominator is bigger. That makes overall quantity here is smaller, so I should use less sign. And here, well, right away I can recognize that it's going to be p series. So yeah, this time it's a very similar idea. So the p series is 1 over n cubed. P series. P equals 3 this time, but still it's greater than 1, so it means that this p series is convergent. And using the same logic, we're going to say if series with the larger terms is convergent or equals to finite sum, well then definitely a series with the smaller terms should be equal to a finite sum. It cannot be infinity. So this series is also convergent by the comparison test. Okay, and put it all together and get the final result. We'll say this one is convergent, this one is convergent, and we know based on the properties of convergent series, if those two are convergent, then their difference is also convergent. So our original series is convergent. Okay, so that's going to be the answer.